Jai Hind. I am Sanjay Sonker, working as an assistant professor in AKGE. In this lecture, we discuss about the introduction of design and analysis of algorithms. First, not only ambition but habits should also be great. Why we discuss this statement? First, we observe that we just compare with Microsoft and Google. In a Microsoft and Google. In a Microsoft, we just discuss about the before or 20 years. We observe that before 20 years, Microsoft having a good hardware, and Google is not good as compatible with Microsoft. Is not good in hardware technology. Second thing is Microsoft having no work on a algorithm, not working algorithms, but Google is continuously working on design a algorithm, design a new good algorithms. What is observe this statement? We observe this statement. If we design, we are focused on designing the good algorithms. The growth is suddenly increases. The cost is increases. So we are focused on only design algorithms. The hardware is not sufficient, but also we are using to focus on designing algorithms. The growth of Google is, you can see that, very high. So we are interested to study the algorithm and design. First, how to define the algorithms. The algorithm is the combination of sequence of finite steps to solve a given particular problems. If a problem is having more than one solution, the algorithm then be the best one is decided by the analysis basis in a two factor, that's a time complexity and space complexity. Just we take an example how to define algorithms. First is, just take example, we added two number, we have a problem. First we have a problem. I have a problem to add two numbers. We write algorithm. First step first, we take a two number. Take a two number A and B. Second step, add two number A and B. Third step, generate a result, that is a return A plus B. Yeah, print result A plus B. That is a three step to design a algorithm. That is a three step. That is a finite step. Step 1, step 2, step 3 to solve the problems. The position of the steps is not matter, but number of a step is a finite to solve the problem. Is known as a algorithm. Now, properties of algorithms. How to verify the algorithms? How verify algorithm on the basis of given properties? That is an important question. First property is, algorithm is a terminate after finite time. It's required to terminate. Every algorithms is required a finite time to terminate. Second is, at least one output. It's having at least one output will be generate. Third point is, algorithms are superset of our programming language. If you write a algorithm for a given problems, then you write a implement with the different programming language as you have decided. First, algorithm is a superset of our programming language, such as you can first you write algorithm, then you implement with C, C++, Java and Python and so on. Second thing is, next is it's a deterministic. This is an important concept. The algorithm may be deterministic and sometimes algorithm may not be deterministic, and most of the algorithms are deterministic. We have just observed that deterministic means if a algorithm A, just take algorithm 1 is a deterministic, it's take a inputs and generate a outputs, it's take a input as a and generate output B on a one day. In the next day, same algorithm is generate same result next day. Okay, this types of algorithm is known as a deterministic. The same result will be generated. Next is a non-deterministic. Non-deterministic algorithms. If a algorithm non-deterministic algorithms, it's generate take a inputs and generate result B in one day, but the next day it's generate another result, that is a C, and next after day is generate another result D. It's known as a non-deterministic. We just take example as a random algorithm. Random algorithm is generate a different output for a same input. Next is a input may or may not be required for a algorithm. There is a 5 terms to verify the algorithm is exist or not. Now, how to construct the algorithm? First, know the problem clearly. First, we know the problem clearly. Is known as a problem definition. Problem definition. You just first we identify the problem clearly in the terms of inputs. We just identify the inputs for a given problems. Second is, after we identify the problems in terms of input and output. Input and output, same as we identify both is, that is a problem. We just identify the input and output for a given problems. Then we design a algorithm. Next step, we design a algorithm. We have a 5 algorithms. First is divide and conquer. Second, greedy methods. Third one is a dynamic programming. Fourth one is a branch and bound. And fifth one is a backtracking. We are using this algorithm to design the algorithm for a given problem. After that, we choose the one of the algorithm which is suitable to the problems, and then we draw the flow chart. After draw the flow chart, we just test the algorithm is compatible for these problems. Yeah, it's give the best solution for these problems. Then we will choosing. Otherwise, we go with again design algorithm. We choose the another algorithm and then again draw flow chart and test the algorithms. And after testing is successfully fine. If a testing is successfully, then we implement the algorithms. It's not as a coding. With the help of coding, we are using to the C, C++, Java and Python. And so another programming language will depend on the programmer interest. After that coding, we are discuss about to the analysis. So we observe that this topic is based on we just focus only, we are interested to focus only design a algorithm. Next is design, and last one is a analysis. First we design a algorithms and analysis. Second is, we observe that design a algorithm and analysis is known as a DAA. Also we can say that DAA, the word AD, DAD, DA, okay, yeah, ADA, that is a different things. Designed analysis of algorithms, yeah, analysis, algorithm analysis and design and so on. That is a point. Now, analysis is basically based on a time complexity and space complexity. Analysis basically based on a time complexity and space complexity. Now we observe that analysis is with the help of two components, time complexity and space complexity, to find the best solution for the problems. Now first we define as a time complexity, next we discuss about the space complexity. Basically space complexity is related to the memory in main memory. Okay, now we focus on time complexity. The time complexity of an algorithm quantify the amount of a time taken by the algorithm to run as a function of the length of the inputs. Note that the time to run is a function of the length of inputs, not the actual execution of a time of the machine on which the algorithm is to run on. Now we discuss about the time complexity. Now we define a time basically defined as this TP equal to time, CPU time, execution time, TP CP plus RP. Now here we discuss about the CP is a based on compiler and languages, and also known as a software, and there is a time taken, there is a time to take a depend on a hardware, is depend on a hardware, or hardware is basically depend on the technology. Here we discuss about the technology, that is a Intel. Observe that Intel i7 IA9, that is a processor, depend on the hardware, that is a processor. Okay, now here that is a fix. If you are using the i7 i9, that is a fix, but the main important thing is a compiler and languages, that is a depend on a software. Okay, most of the parties depend on a software of execution time, that is a languages. Okay, we observe that time complexity, space complexity, and another is a resource. First we observe that if a time, just calculate the time, just observe that if algorithm, I just take example 1, if algorithm A time complexity algorithm A and compare with another algorithms and compare with algorithm B. Now observe that the time, first we observe that time to run the algorithms, running time of the algorithm, execution time of the algorithm is order of n square. We discuss about the order in later. First we observe that the order of n square, that is a algorithm 1, and another is B execution time, algorithm B execution time is same as n square, both are same. We have another problems, how to identify which algorithm is suitable. Time complexity is equal, then we go for the space complexity. Now we check after that we check first time complexity, next time we check the space complexity. Now we check the space complexity of the algorithm A. Space complexity, just observe that n, order of n, same as, yeah, here we observe that space complexity of B is same, time complexity is same, both algorithm, space complexity is same. Then we reach to the resource complexity. Okay, most of the time we just find the time complexity, which algorithm is just suitable for the problem. Just another, we just take another example here. You just observe that you easily identify. Now take another example. If a algorithm A having a execution time complexity of order of n square, algorithm B having a time complexity of n. Which algorithm is suitable? Which have a high complex time complexity. That is a higher time complexity. That is a less algorithm will select with B. Okay. Now we observe that time complexity for a constant, just observe it as a input and computation times. That is a computations, and input size is n, constant is order of 1. Next is logarithmic, order of log n, linear, order of log n, order of n. Next is log, linear, order of n log n, quadratic, order of n ki power 2, 3, 4 and so on. Next is a, that is known as a polynomial. That's a exponential is 2 ki power constant, c ki power n, that is a constant. Polynomial is order of n ki power n, that is a polynomial. Okay, 1, 2, 3, 4 and so on, and that is a n factorial. There is, okay. Now we just take the increasing order of time complexity. We just write the increasing order of time complexity is constant, order of 1. Next is logarithmic, that is the increasing order is order of log n. Next is order of n. Next is n log n, linear logarithmic. Next is a order of n, constant. Okay. Next one is a order of exponential, constant power n, that is the increasing order, and the last one is highest factorial n. Okay, that is the increasing order. That is the increasing order. Okay, that is a typical function. Depend on the inputs. We just take inputs of 10. We just take input of 10. Log n, log base 2 n equal to 10. We just compute this, n equal to 10, and log n is greater than. Yes, observe it. Take it. Now we discuss the analysis. That is a very important concept, and this subject is based on the a priori algorithms. But we discuss between the a posteriori algorithms and a priori algorithms. First, we just observe the comparisons. Most of the algorithms in here we most of the algorithm based on a priori. Algorithms. We just take a difference. First, it is dependent on a language and compiler and types of hardware. Posteriori algorithm basically based on depend on types of hardware. Observe it. Now, a priori algorithm. A priori algorithm is basically independent of languages and hardware. It's not depend on a compiler and hardware, but a posteriori algorithm is depend on a compiler and hardware. Second is it will give the exact answer. A posteriori algorithms give the exact answer, or a priori algorithm is give the approximate answer is based on a human mind. Okay. Next, observe that the answer will change from the system to system. That is a drawback of a posteriori algorithms is the answer result will be changed according to the hardware will be changes, but in the a priori algorithm is the answer will be same for every systems. Okay. Next, observe that is a very important point. Observe it. It doesn't use the asymptotic notations to represent the time complexity of the algorithm, but a priori algorithm is use the asymptotic notations to represent the how much time to the algorithm will take in order to the complete the execution. That is a order of magnitude of statements. Okay, so most of the algorithm is based on a priori algorithms. In this subject, we are our algorithm is based on a priori algorithm. So we focus on the a priori analysis. Now, what is the a priori analysis? A priori analysis is basically based, it's defined as a determination of the order of magnitude of a statement. That is known as a priori analysis. I am just taking some example to how to identify the time complexity. First, we just take an example. We just take a program. First example is a main. Now, we just take a x equal to a plus b. That is a statement of a program. What is the output of these programs? That is a only one statement of, we just find the magnitude of the statement is order of 1. That is the execution time. Okay, that is a single statement. Execute in a order of 1 time is a statement. That is the first example. Now observe that. Okay, another example, main x equal to a plus b, just a pseudo code. X equal to a, we just take another for I equal to 1, I is less than equal to n, and I is plus plus. That's the increment. Okay, and x equal to a plus b, that is a print f, print x. Okay, yeah, just take a print x. Now we just observe that the problem. That's second example, main first statement, that is the first statement, execution time of the first statement is order of 1 time, and second having a for loop, is a for loop. For loop is execute for a n times. Yes or no? First I equal to 1, that is a print x. Next I equal to 2 is print again this statement. 3 is print again statement. For a n times is print this statement. That is a loop. That is the time complexity of this loop is going to with n times. That is a order of n. That is a loop. In these types of a problem, we just identify the execution of the program. The total execution of the program is, just observe it, n plus 1, n times for loop, 1 time for a statement. The total time is order of n. Why? Because the for loop is dominate to the statement, single statement. We just identify the largest for loop in a program, that is the execution time of the program, that is the order of n. Just take another example, same, mean x equal to a plus b, that is a statement. We'll take another for loop I equal to 1, I less than equal to n, and I increment, and another nested for loop j equal to 1, j less than equal to n, and j plus plus. Observe that x equal to a plus b, and print x. Just observe it. Okay, observe it. In this programs, first observe this, that is a statement order of 1 time. Next for loop, in the nested for loop going with there, for every value of I, it's run to n times. Okay, for every value of I is run to n times, for I equal to n times, for I equal to 2 to n times, for 3 to n times. So that is a n into n, order of n square. Let's give the n square. The biggest loop is, observe that, n square plus 1, which is dominating, n square is dominating, so big O of n square, the time complexity of this program. Okay, next observe it. Example 4. Now we just take it, combine them. Now more clearly, a plus b, 4, 1 second, it is for I equal to 1, I less than n, I plus plus, it's print x equal to a plus b. Okay, another for loop, I equal to 1, I less than equal to n, I plus plus. Now we just take another for loop, nested for loop, j equal to 1, j less than equal to n, j plus plus, and just we use to print the x equal to a plus b. Okay, and just observe this statement is generate constant time order of 1. This for loop is generate output is order of n, or this for nested for loop is generate the time is order of n squared. The combined time complexity is n square plus n plus 1, which is dominating. Biggest for loop is this one is the largest for loop, first, that is the largest loop, that is the dominating to the another. So the time complexity is big O of n square. So simply we just identify the largest loop in a program, that is the time to execute the program, whole program. Okay. Now I am just taking another example. Mean I equal to 1 while I is less than n. Okay, I is less than n and I equal to I plus 1. Now we just find the complexity of this program. Now observe this program. If a n is just take a n is, we just take a n is 10. Okay, we observe that n equal to 10. First I is initialize 1 is less than 10, that is a 10, that is a 1, and that is an increment 1 plus 1, that is a 2. Next going to the 2 compare with 10 is less than, it's execute. Okay, that is a 3, 2 plus 1 3, same as 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 6 plus 1 7, 7 plus 1 8, 8 plus 1 9, and 9 plus 1 10. Okay, when the condition is matched, that is a terminate. It's not equal to the termination, the program will be terminate. Here the termination is given as n here. Okay, terminate is n times, it's reached with n plus 1. Okay, that is a, and just observe that 1 plus, just observe it, 1 plus, here we observe that I equal to 1, 1 plus 1 2, okay, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 6 plus 1 7, 7 plus 1 8, and so on. Observe it, that is the value is I plus, that is the value is 1 is fixed, but I will be increased, that is a 1 plus k times equal to n. Termination condition is n minus 1, that is a k, that is a termination conditions. The complexity of this program is big O of n minus 1, that is a big O of n. Okay. Now we just take another example to understand the problem. Observe it. Example. Mean I equal to n, while I is greater than and equal to 1, that is a termination, that is a condition is true, that is a while loop is executed. If if I is less than 1, the fail. Okay, observe that I equal to I by 2. Observe it. Okay, first you observe it. I equal to n. Okay, n is given as, just take example, n is given as a 64. Observe it. I equal to n. Okay, just observe it. Observe it. It's divided by 2. Yani n. That is I equal to n divided by 2. Okay, is greater than 64 is greater than 1. It's divided by is a 32. Observe it. Is it divided by 2? That's a 32. 32 is again greater than 1. It's again divide. 60 is greater than 1. Again divide. 8 is greater than 1. Greater than 1. It's again divide. 4 is greater than 1. Again divide. 2 is greater than 1. Again divide. 1, that is a fail condition, equal to, that is a 1. Okay, it's a fail, terminate, that is the condition is fail. Okay, now observe it, answer, that is a, now that is a, observe it, the series n divided by 2, next is n again divide by 2 to the power 2, next divide n divide by 2 to the power 3, n divide by 2 to the power 4, n divide by 2 to the power 5, and n divide by 2 to the power 6, and so on. Yes or no? That is a n by 2, it's reached to the termination condition. If I is less than 1, that is a terminate. Now observe that the series is n upon 2 to the power k, and termination is 1, that is a termination condition. Termination is equal to 1. Now observe it, n equal to 2 to the power k, taking the log both side, take a log both side, log n log base 2 k equal to log n. Now the execution time of this program is defined as a big O of k. So big O of log n. The answer is execution time is big O of log n. Here the base is 2. Observe it, log base 2 log base to n, that is the execution time. Now we just change the sum, again we will be changing is 3. Now observe it, observe it. Now just take the another color to understand. Observe, we just change the value of 3. Now in a loop the value is I equal to I by 3. Now same as here n by 3. Observe it. Problem different but concept is same. Now we have observed the, okay, last we discussed about the, here this problem is same but concept is same but problem change. change the problem. Now here in a log, we just take I equal to n, so n by 3. Next is n by 3 की power 2, n by 3 की power 3, n by 3 की power 4 and so on, n by 3 की power k, that is a last term, the kth term, or kth term is terminate with 1 equal to 1, n by 3 की power k equal to 1, n equal to 3 की power k. We just taking the base log base 3, log base 3 n equal to k. The execution time of this program, order of log base 3 n. Now we observe that here the base is the log base is using in the while loop statement, is a while loop statement. Okay. Now we stop here and we continue this lecture to the next lecture. Okay, thank you.